Hi, welcome to the lab on heat diffusion. So you should have the lab paper handy because the equations you'll need are located right here, as well as the procedure that we're going to follow. The numbers you're going to write down go on this data page. So the numbers go on the data page. If there's some missing numbers, I will tell you where to put them. The first thing we need is the mass of the cup. Now you can see from our apparatus, or at least I hope you can, that what we have is we have a large cup that has a support ring in it, and that is meant to hold the smaller cup. And the smaller cup is the one we're going to measure. So we need to know its mass. I'm going to turn on the digital scale. Hopefully turn it so you'll be able to read the numbers. I'm going to put the empty cup on the scale. Now, sometimes with the glare, this number is hard to read. Remember, this is in grams, and it has 3 digits, but there's a decimal point between the last digit on the right and the first 2 digits. So you have 2 digits, a decimal point, and then the last digit. All right, we need to take this cup and we need to put some water in it. Now this water, I'm going to put it about halfway in. You can see I've got water in my cup, halfway. And what we want to do with that is set it on the scale and come up with its value. So I have a number on the value for that. And again, I'll try to hold it steady so you can read the number. Now in this case, we have 4 digits. We have 4 digits. And so you have 3 digits, a decimal point, and then the last digit. I'm going to take that and put it in the container. We're going to weigh, this little metal thing is the stirrer. I'm going to put it on the scale and we'll find its mass. So again, I'll turn hopefully so you can read the number. I know it's very fuzzy, I'm sorry about that. So 3 digits, the first 2 a decimal point, and the last digit. I don't know if I can get out far enough so it's clear. 3 digits. So you've got 2 digits, a decimal, and the last one. Okay. So we put the wooden lid on top of our container. Whoops, we're going to put the stirrer in there. My mistake. It's going to go through, and we will. So I've got the stirrer, a wooden lid, and my water is inside. I need to know the temperature. As you can see, I have a little digital thermometer. It's set on degrees Celsius. It also has 3 digits. Right now it's reading 21.1 degrees Celsius. You don't need to write that down. That's room temperature at the moment. We need to know the temperature of the water. And so we will get that right before we add our ice cube. We're going to get it right before we add the ice cube. So we will see that our temperature is still going up. It says, what does it say? Oh, I'm awful fuzzy here. Again, it's really hard to read. My apologies. I'm getting a reading of 36.0 degrees Celsius, 36.0 degrees Celsius. Whoops. Yeah, it's fluctuating, 36.0. So that's going to be our starting temperature for the water, the cup, and the stirrer. And now what we want to do is get a piece of ice And we want to make sure the ice isn't coated in a layer of water. And so I'm going to dry it off with a paper towel. We want it so it's not coated in water. We'll dry it off as best we can with a paper towel. All right, the initial temperature has changed. It's 35.8, 35.7 degrees Celsius. I'm going to put in our ice cube. So it was 35.7 was our starting temperature, 35.7 degrees Celsius. We're going to put in the ice cube. And I am going to, let's see if I can get our camera up high enough so that you can see the thermometer. All right, I'm going to stir and it's going to change. I'm not sure. Whoops, I'm going the wrong way. Oh my goodness. This was supposed to make it easier and I don't think it has. So it's dropping rather rapidly. 26.0. It's still dropping. It's kind of a big ice cube, so it might drop. Well, now it's slowed down, but it's dropping again. I think I'll give it a stir. What that does is it sort of redistributes the water so that the ice cube melts a little faster. And now we're down to 24.1 degrees Celsius. We'll see if it's going to drop at 24.0. It's continued to drop. All right, I'm going to stir it a little more. Let's see what we've got going on. All right, it's going back and forth between 22.9 and 22.8, and it seems to have stabilized at 22.8 degrees Celsius. So that'll be our final, whoops, I lied. It's continuing to drop, okay, fine. We're at 22.1. 22.0. 21.7. 21.5. 21.3. 21.1. 21.0. And continuing in our downward spiral, okie doke. 20.9. All right, I'm going to call it at 20.8 degrees Celsius, 20.8 degrees Celsius. So that's our final temperature. We're going to have to come back and use our scale again. So we're going to take the thermometer out and put it to the side. The thermometer comes out and gets to the side. The lid comes off and gets put down to the side. So I've got the thermometer and the lid. And we're going to leave the stirrer in it because it has water on it. And take it out. And we're going to put, whoops, I have to turn it on. Turn on the scale. Put the cup with the warm water, the melted ice cube, and the stirrer on the scale, and we get a number. So again, 3 digits to the left of the decimal, 1 to the right, and it's in grams. I'm going to write that down. And now we are to the point where you have to do your calculation. So, let's take a quick look at this page, see if we can make some sense out of everything. So on your data sheet, you should have a number for the mass of the cup in grams that you're going to convert into kilograms. So be sure to convert it to kilograms, some number in kilograms. The number is not 0. You will have written it down when we were doing things. The specific heat of the cup is 900 joules per kilogram degrees Celsius because it's made out of aluminum. The initial temperature of the cup was that starting temperature that I gave us. You should have written it down. I'm afraid I altered it after we began because by the time it's the temperature right before we added the ice cube. The mass of the stirrer, you know, again, you want to write it down in grams, but be sure to convert it to kilograms because we need it, all our masses in kilograms. The stirrer is made out of the same thing as the cup, and so it will also have a specific heat of 900 joules per kilogram degrees Celsius. The initial temperature of the stirrer is the same as the initial temperature of the cup. We will have the mass of the cup, warm water, and stir. Now this is we didn't actually write that as a single number. We did, actually, let's strike the and stir out and just say mass of cup with warm water, because that's a number we recorded in grams. You have that number. And again, you're going to want to turn it into kilograms, so be sure. So the mass of the warm water in the cup. So it's going to be the mass of the cup and warm water minus the mass of the cup. That should go right here. And again, we want the final answer there in kilograms. Specific heat of the water is 4,186 joules per kilogram degrees Celsius. The starting temperature of the warm water in the cup was the starting temperature of the cup and the stirrer. So we have 3 places where the starting temperature is the same. Now the mass of the ice in the cup and the stirrer and the warm water, that was our last mass. So one we got when we put it on the scale. And again, you want your answer in kilograms, so be careful. And then finally, you need to calculate the mass of the ice added to the cup. So you've got ice, cup, stir, warm water. You've got cup, warm water, stir. Oh, I'm sorry, not stir, cup, warm water. And you've got the mass of the stir. So you've got enough things you can do some subtracting to find the mass of the ice. So you should find the mass of the ice by subtracting some of the previous numbers from this very last number we recorded. The specific heat of the water is the same as the specific heat of the melted ice, which is 4,186 joules per kilogram degrees Celsius. The starting temperature of the ice water, the melted ice water, is 0 degrees Celsius. And the final temperature of everything was our last temperature reading. All right, it was our last temperature reading. So you should be able to take all this data and use it to calculate the heat of fusion. So your calculation sheet is going to look a little different from this one. I have altered it for you. It still works on the assumption that heat loss plus heat gained is 0, but I'm breaking it down into 5 individual calculations. And then finally, you'll do percent error, and then you'll be done. So that should finish us. Good luck.